Hello everyone, welcome to Coder and Boots. So in this video, we are going to discuss about the topic how to containerize your Python application. Okay, so this is a very fundamental thing that is required by every developer. So because nowadays everything is getting deployed as a containerized application. Okay, so let's get into the topic. So how to containerize? Okay, so what are the steps involved in containerizing an application? So in this example, I have taken a Python project. So it's a simple Python program, and I'll be containerizing for deploying it in a Docker server. Okay, so first we need a Python project. Okay, so it can be any Python project. In my case, I'm going to demonstrate this with a simple Flask API. Okay, second thing is, if you are developing a Python program, there will be dependencies and configuration. Dependencies means all the dependent packages. So the dependent packages can be like the packages that is available in the PyPy repository. So for example, in my case, I have developed a Flask application, so it needs Flask package, and it so in your case, I mean, if you're developing a very complex application, there can be n number of Python packages as the dependencies, and some of these dependencies will internally have some dependencies in some Linux packages as well. So in that scenario, you will need the list of Linux packages that is dependent on the that is basically the internal dependency of the Python package. So we need to have a proper understanding of what are the dependencies of your Python program. So the Python packages and the Linux packages. Okay, so then the configuration. So in this example, as my program is very simple, there is not a lot of configuration, but in your case there can be configuration. We are not going to discuss about passing environment variables in this example, so I'll explain, as it is a different topic, it needs some more discussion. I'll explain it in a different video. So assume like we are bundling the configuration as part of the container. Okay, so next is we need a base image. So what is base image? So base image is the foundational image or the basic image which is required for our container. So on top of the base image is where the packages or the dependent packages will get installed and our Python program will run. Okay, so we need to identify a right base image based on our application. So in my case, I am going to use a very simple program. So I'll be using a simple Python base image. So it is available in the Docker registry. So I'll show you what base image I'm going to use. Okay, so then once we have the base image, what we do, we will create a Dockerfile. So Dockerfile is a file where we define the entire spec of the container. Okay, so it's a very simple text file. So I'll show you how we define it. Okay, so once we have all these 4 items, okay, so Python project, dependencies, configuration, base image, Dockerfile, once we have all these 4, we are ready to build the image. So we will build the image of our program. So that will be an image that is on top of this base image. Okay, so base image plus this dependencies plus this Python project, that is going to be our image. Okay, so once we have the image, then what we do, we will deploy the image into the or we will run the image. So once we run the image, it will become the container, right? We will run a container, we'll deploy it into the Docker and run it as a container. Okay, and also before that, one more step we need to do is we need to push the image to the container registry. So there are a number of different type of container registries available. So like GitLab is providing container registry, you have container registry from GitHub, you have container registry from Docker Hub. Okay, there are a lot of container registries available. So depending upon what container registry you are using, you can push the image to the container registry. Okay, so that is how we containerize an application. It is very simple. So and in this maybe 15 to 20 minutes, we will learn how to containerize your application. So you can follow the same steps for any other programming language as well. Let's say you have an application in Java, or you have an application in Node or whatever. So you will be able to containerize it in the same way. Okay, so let's get into the practical part. So one thing, so here I'm going to use like so if you go to hub.docker.com and search for Python, you will see the base images available. So there are a lot of images. So we are going to use a very small base image. So because our Python program, so the program that we are going to use is a simple program. If you see, it has only 12 lines. Okay, so import Flask, then we are just creating the app, and we have a get method that is a hello world function. So it is accepting any request coming to /API. We are going to respond back status success. Okay, so that is a simple API, and we are running it, and the port is 9090. Okay, so this is a very simple Flask application. So as this does not need a lot of dependencies, it has only one dependency. Okay, so that is what I have defined in the requirements.txt, that is Flask equal to 3.0.3. So one thing you need to make sure is always make sure you have a proper structure, package structure followed in your application. It's not a technical problem, but if you just dump everything as like all Python programs in a simple folder and try to containerize, the problem is it is difficult to manage over a period of time. So I would recommend, I mean, it is not a technical problem, but it is more of like a management problem. So make sure you follow like a proper package structure in your Python application. So I have already explained about the Python application structure and all in a different video, in a previous video. Okay, so and one more thing is you need to make sure all the dependencies, the Python related dependencies are listed in the requirements.txt, and make sure you have the version specified, because if you don't specify the version, it will always get installed the latest version of that package at the point of time of installation. Okay, so if let's say today it's 3.0.3, tomorrow it can be 4, okay, or 5. So and maybe based on that, the internal functionality of that entire package might change, so it will break, so application will break. Okay, so just to avoid all those, make sure you have the version specified in the requirements.txt. Okay, so once we have all these, now the next part is we need to create the base the Docker file. Okay, so Docker file is a simple text file. So it's like, I mean, write new, or right click on new, and just a file, it's a text file, and here we define the specification of the Docker container or Docker image, we can say Docker image. Okay, so here the first line is from. Okay, from the here is where the base image comes. Okay, so this I have taken a base image from the official Python repository, that is what I showed here. So hub.docker.com/python, and here if you see, there are a lot of tags available. Okay, so you can pick one of the tags from here. So I've taken so 3.12 slim bookworm. Okay, so this is what I have taken, but you can pick up any Python tag based on your choice. Let's say you are developing a data science related or a complex program, so then you may need to use a different tag which will contain more packages and all by default. Okay, so I'm going to use a very simple one, that's why I used like something with slim bookworm kind of. Okay, so and next line is work dir. Okay, so work dir is basically in the image. So here this is the specification of the image, right? So base image is this 3.12 Python, and then on that, this directory work dir is a place where I mean, we can say like, I mean, the working directory. Okay, so where it will create a directory if it doesn't exist. So by default anyway, this directory will not be there, right? So it will create a directory in the /location /work /Flask API app, and then the cursor or the present working directory will be this directory. Okay, /Flask API app. So inside, what we are doing, we are requesting it to copy dot means everything inside this. Okay, we are requesting to copy everything inside this to the current directory. What is the current directory? It is a Flask API app. So everything from this our Flask API app gets copied to the directory within the image Flask API app. So that means our entire project content will get copied. Okay, so the next part is we are going to install run. Okay, run pip3 install -r requirements.txt, because we need to install the dependencies, right? So we have to install this requirements.txt, and as we have the packages mentioned here, it will get installed inside the image. Okay, suppose that what we are doing, as we don't have any other changes or anything required, so we are just executing. Okay, python3 app.py. Okay, python3 app.py, what will happen? It will simply run this program. Okay, it is similar to what? Run app.py. So whatever we are doing here, right? It will do the same thing. inside the Docker image. Okay, so simply app.py. But let's say if you have any dependencies to be installed, okay, so then Linux dependencies means Linux level dependencies. Okay, so then what you can do run apt get install some package. So all those things you can do. So depending upon what you are defining inside the Docker file, the length of the Docker file and the complexity of the Docker file may vary. But here I am explaining a simple one, that's why it has only 5 lines. Okay, so I hope the Docker file is clear. Now what we need is we need to get into, so I am developing this program in a PyCharm within my Windows machine, and I am going to build it in a Linux machine. Okay, so that is what I am going to do. So in a different video I'll show you how to create an image from the computer itself or from the PyCharm itself using Docker desktop. So but here I'm going to show you from a Linux machine. Okay, so this is my Linux machine, and I have copied the app.py Dockerfile requirements.txt here. Basically the entire project I have copied. Okay, so the project I have copied here, you can see Flask API app, and let's get inside this. So now we have Dockerfile. Let's see what is inside the Dockerfile. So we have the Dockerfile. It's the same Dockerfile, cmd app.py. Now let's build it. Okay, and when we run, what we are expecting an API running in 9090 port, right? So let's run it. Let's build it. The command to build is docker build. Okay, so let's just hit docker. You can see a lot of options here, right? Run, exec, ps, build. So build is the option to build an image from a Docker file. So build is the command that we need. So docker build. So let's see the options under docker build. Okay, docker build -- help. If you give help for that specific subcommand, it will give you the remaining option. So you see there are a lot of options. So docker build and -f. Okay, -f, if by default it will be expecting a Docker file with the name Docker file itself in the local path, in the local directory. But if you want to specify a different Docker file in a different path, okay, you can specify using -f. Okay, and then T is the tag. Okay, so whatever image that you are creating, right? So that image name and the tag you can specify using -t. So we are going to frame a simple command, docker build. Okay, docker build -t. Okay, Flask app. Okay, so colon v1. v1 means Flask app is the name of my image, v1 is the version. Okay, so then where is my Docker file? My Docker file is located in my current directory. Okay, so that is why I am giving dot. Okay, so docker build. I am running this command from the place where I have all the Docker files and the other project related artifacts. So it will run. Okay, the interpreter will run through the Docker file and build the image. Let's see what happens here. You see, it's building, and internally, if you see, it is going line by line. Okay, so it is pulling the Python base image, so the 3.12 slim bookworm, and then it downloaded, then it created the work directory, copying, okay, pip install requirements txt, right? Then it's creating the image, and now the image is ready. Now let's see Docker images. Let's list the images in this machine. So you see Flask app v1. Okay, it is created over here, Flask app v1. Okay, so it is created. Now what we will do is we need to run this image, right? So we need to run this image. How we will run? So the command is docker run, okay, -itd, okay, and then this image colon version we need to specify. Okay, docker run -i -t d for detach. Okay, so here also if you want to understand what is the detail, what are these options, right? Docker run -- help will help you. Okay, will give the complete option. So if you just do docker run -help, it is giving the options, right? So what we have used like -i, right? So where is the I? Okay, interactive, right? Then docker run, then -i, then t. Okay, t is tty, allocate a sudo tty, then itd, d for detach, right? D, where is D? D. D means detached. Detached means by default, if you're not specifying D, what will happen? The terminal of the image will open up. Okay, but I want to run this image in the background. That's why I'm going to specify -D. Okay, so the default command docker run options image. Okay, so image is what? So we have given docker run -itd, and then if you want to specify a name, okay, what you can do is -- name you can give flask app. Okay, so flask app -itd, maybe flask app v1. I am giving docker run -, this is a friendly name. Okay, so for the container -itd, and let's specify the image whatever we have built, right? What is the image? It is flask app :v1, right? Flask app :v1. So I am just highlighting the command again. Docker run name of the container, you can give any name, -itd flask app, then the tag version, okay, v1. Now you see it executed. Now docker ps, you see the container is running. Okay, but now the problem is how will we test this container? So one is we can get inside the container. Okay, docker exec, then the container name, okay, /bin/bash. Okay, we can get inside the container. Wait. Docker exec -help we can check. So docker exec options container command, right? So we want to get into the shell of the container. Okay, and what we need is we need interactive, right? TTY. So what we'll do, docker exec -it bin bash. So now we got inside the container. Now you see previously it was root at cib. Now we are root at this id. Okay, so we are inside the container. You see the container id, right? The host name is the container id. And now if you see curl command might not be there because it is a Python image, right? So we can install curl inside. Okay, apt install curl, apt update we need to do, apt update. Okay, so because internally the Python base image, it's a Debian image. Okay, so its parent image is a Debian image. That's why apt command is working. So we can install curl on top of this. So if you want this curl and all by default, right, what you can do is you can specify all these packages in the Dockerfile, so that you don't have to install it again and again. Okay, curl http :/localhost 90/API. Okay, see, it is internally giving status success. Okay, I am able to hit this API, but how to get this API accessible outside? Okay, that's a problem, right? So I'll show you one more thing. So I came out from the Docker container. Now if you see, this is my machine. Okay, now if I have Docker server running here. So if I type ifconfig, here if you see, there is an interface called Docker 0. So this is the network that is created by default by the Docker. So whatever containers I deploy, so by default it will deploy in this network. Okay, so this network is different from my machine's network. Okay, so that means whatever container is running, if you inspect that container, okay, docker inspect the container, you will see an IP address internally allocated to this particular container. You see this as in the network settings of the container. So if you do inspect, it gives the complete information of the container. Okay, it tells you, like, I mean, what is inside, right? So when was it created, when was it started, all those information it gives. And there is a network settings under the container information. So inside that you will see the IP address which is allocated to the container. The IP address allocated to this container is 172.170.13. Okay, let's see. So as my Docker server is running in the same machine, okay, so this 172.170 series IP address will be accessible from the same machine. Okay, but if it is running in a different machine, I will not be able to access, because the network will be within the Docker network of that other machine. Okay, as it is in the same machine, I will be able to access it directly. So curl http, okay, so colon 9090/API. Okay, now you see, when I try with this 172 series IP 9090 API from the same machine, I am able to access. Okay, but let's come out of this Linux machine. Let's try from the Windows machine. From here, let's see, it's not working because my Windows machine is connected to a different network. So how can we access this, or how can we expose the API from this machine outside? Okay, so what we can do is, in the Docker, while running the command, okay, while doing the, so what I'll do is I'll stop this PS. So I'm going to stop this Docker stop. Okay, I'm going to stop this container. I'm going to remove this container. I'm going to start another container. Okay, Docker run, okay, -itd. Okay, so before that, hyphen name. Okay, I'm giving Flask app v2 itd. Then I'm going to specify my image Flask app v1. Okay, so before that, I'll specify another thing, -p. Okay, p is for port mapping or publish. Okay, publishing a port. So I'm going to expose 9090 of what is inside the Docker container to my host, my laptop, my Linux machine's network. Okay, so this will do a mapping of the container network to my Linux machines, or where the machine where the Docker server is running, right, to that machine's host port. The only thing is, we need to make sure this port is free in the host machine. Okay, so -p is basically the option for publish, and on the left hand side, whatever you see is the port in the host machine, and on the right hand side, whatever you see is the port on the on the container. Okay, now let's run this. Now if you do Docker ps, you will see under the port section. So previously, when we did Docker ps, under the ports there was nothing. Now you see under the ports, you can see there is a mapping. Okay, from host 9090 to there is it's mapped to 9090. Okay, now let's see curl so ifconfig, right? So let's get the IP address of our host machine. Host machine's IP address is 192.168.5.28, right? Curl -x get. Okay, http:// this host machine's IP address /API. Okay, now you see it's able to give success. Now let's try this port from our laptop, Windows laptop API. See, I am able to access this port from my Windows laptop as well. So now we have successfully deployed the Docker image, and successfully built the Docker image and deployed it as a container in the Docker server. Okay, so we have it running here. So now next part is the only the missing part is how we will push it to the Docker registry. So what I have done is I have created a Docker hub account. Okay, so what you can do is you can go to docker.com and create an account. Once you create an account, you will get a console like this, and from there what you can do, you can create a repository over there. So this is what hub. Okay, go to hub. If you go, then this is Docker hub. You usually see almost all the base images in this Docker hub. There you can create a private or a public repository. So I have created, okay, you can create the repository using this option, create repository. So you can create repository, you can specify the visibility, whether it is public or private. Private means it is visible only to us, and public means it is accessible to everyone in the internet. Okay, that is how we have this Python image registry, the Python official image, right? It is all hosted in the Docker hub. So I have created a repository over here, and then within the repository, what we can do is, once we have the repository, we need a credential to be generated. The credential can be generated by clicking on the account, right? On the account section, go to account settings, and then you can create something called personal access token. Go to personal access token, you can generate a token here. So this is equivalent to a password. Okay, so you can log into this particular registry using docker login command. Okay, docker login, and whatever username you have specified in this particular repository, right, that username you specify, then what will happen, you can enter the password, then the login information will be retained in the docker server. So what I'm going to do is I'm going to push this image, whatever I created, right, I'm going to push it to this repository. And if you see, what is the command to push, we use something called docker push. Then coder in boot is my my registry name, and coders API is my repository name. Okay, so coder in boot / coder API. So this coder in boot, whatever name you are specifying while creating this hub, right, so that is a unique name. Okay, that is and that will be unique across this hub also. So this one / whatever repository name, and then the tag. Okay, so but in our case, whatever image that we created, right, docker ps, so no, docker image. So our image is the name of the image and the tag, right, it is different from the repository that we created, right. So we need to tag it, okay, or we need to tag it in a different way. So for that, what we need to use docker tag command. Okay, so docker tag command is simple. Docker tag and our current image, and then the image that you, or the name of the, or the structure of the or the name of the image that you see in the Docker hub, right, that is the format. So what we are going to do is we are going to frame the docker tag command. So it will look something like this. So what is our image name? Flask app v1, right? So flask app, docker tag flask app v1, then coder in boot, coders API v1. Okay, so in this way, what will happen, the image will get tagged into a different name. Okay, so whatever we have it in flask app v1, right, so it gets tagged. So you don't really need this two-step process. If you by default, when you're creating the image, if you're creating it with this name, you don't really need this circus. Okay, so I'm going to create this tag. Now you see docker images, it created a different tag. Okay, but the image ID is the same. Image ID is the same because the content of my previous image and the current image are the same. The size is the same, the contents are the same. That's why it is just an alias internally. Okay, it created a tag out of this one, another tag out of this the previous image. Okay, now what we need, we just need to execute docker push. Okay, coder in boot / coder API, then colon the v1 version, right, v1. Okay, now we just do push. So you can see it is pushing it to the remote repository. Okay, so once we push it, then it will be accessible from everywhere. So let's wait. So it will be pushing to the remote repository which is present in the internet. It will take some time. So depending upon the size of the image and the speed, bandwidth, right, whatever you have, so it will take some time. Let's refresh this. Once it is pushed, right, it will come in the under the tags section. If you go to tags section, if there is an image, it will show up there. Yeah, now you see it is pushing. So it is pushing the image. So in production scenario, we will do scanning and all before we push it, so that we will make sure like there are no vulnerabilities associated with the created image and all. So now let's refresh this tag section, and you see the image got pushed. Okay, the image got pushed. I'll quickly show one more example. So instead of like doing this retagging, we will create an image with the name. Okay, so what we'll do is we'll create an image with the name of the repo itself. Okay, so docker build -t coder in boot / coders API. What I'm going to do is I'm going to create a v2. Okay, I'm going to create a v2. So in this case, we don't really need to tree tag it. Okay, think about like we are creating this image for the first time. Okay, so I am creating it, Now the image is ready. Now Docker images, see, now we have coder input, coder API, v2 is available. Now Docker push and this colon v2. Okay, so now it is getting pushed. Now Docker ps no, so now here if you come to the tags within our registry, you see the v2 got pushed. Okay, so building and pushing this image is very easy. Okay, as I have explained it through several steps, that's why it took some time. But as you see here, when I tried to build it for the second time, right, it built in just a minute, right? So depending upon whatever you have inside the Dockerfile, the steps may take some time, but I'm saying, I mean, the overall complexity is very easy. Okay, it is not complex. Okay, so I hope this this video is useful. So if you have any questions, feedbacks, comments, feel free to comment below this video. So I'll definitely respond back. Thank you very much for watching this video. Have a nice day.